So I bought these beams along with some other used steel from a friend about 4 years ago while I was actually still working on the spec house project. And I've been waiting and watching ever since for the right project. And these gate columns, I knew instantly was that project. Now the first chore was to get these things cleaned up. So I took them to my friend Curtis Evelyn, just up the road, who sandblasts and paints all things metal. Because repurposing steel makes good sense in most cases, particularly with larger beam sections like these, and it's a lot easier if they are in, somewhere close to new condition when you start to put them to work. These beams are a type of an I-beam that is commonly referred to as an H-beam, or simply wide flange, because of their section, obviously. The width of the flanges is much greater than the depth of the web compared to normal I-beam configurations. And these are 7 3/4 deep, 6 1/2 wide, and now, my friends, I have to confess to you what happens when an old man makes a gate design and confuses those two dimensions, the width and the depth, when he starts deciding what he's going to do. So I'm still not sure what happened. And unlike the other big mistake I had to confess to you about tearing out those stairs at the spec house, where I simply was unaware of a code change, this design blunder was all my fault. Somehow, when I was putting together the plan for the columns, I switched the width and the depth and had decided that 3 beams 6 1/2 inches wide would fit nicely on my concrete piers. Problem is, even after all of the head scratching and drawings that I made and, asking other people's opinions and even showing you my intention, I had somehow got my wires crossed and not remembered that the width of 6 1/2 used on the face of the approach to the gate would block off access to the anchor bolts inside on the base plate. It just wouldn't work. And besides that, it wouldn't have looked good. I had been imagining one appearance, but I drew a different method. This makes me nervous. I've been around other old men who begin to slip and make silly decisions and overlook site conditions and timing and processes and sizes and schedules, and those mistakes can cost a lot of money. So, with my confidence more than a little shaken, I came up with a fix which I think is in fact going to look good and be good, and we're moving forward anyway. Sometimes you just got to do that. And this, for me, is one of those times. I've got some 5/8 diamond plate here that I'm going to use for the base plates on the columns. I'm not cutting it with my plasma cutter because my little Hypertherm maxes out around 1/2 inch or 5/8 thick, and it gives kind of a raggedy and somewhat erratic cut, at least the way I operate it. So I'm going to use a cutting torch, an older school technology, but really good in a pinch. I've put a brand new #1 tip on here. I've turned the oxygen up to 35 pounds, and the acetylene is, 8 or 9, something like that. I want a hot, clean, effective, hard-pushing cutting tip as I try to burn my way across this 5/8 diamond plate that I had, by the way, sandblasted so that I don't have the additional complication of rust and dirt and buildup. It's a nice, clean piece of steel, and let's see how it cuts. Repeating myself, a sharp cutting tip is an exact analog to a sharp skill saw blade, and feeding a little faster is better than feeding too slow. As long as you're not overrunning your molten pool and, running out so fast that it just won't cut it that quickly, you should be moving just about as fast as it'll keep up, and it minimizes, I guess, the amount of slag that's attached to the bottom of the cut. At least that is what my fairly limited experience is leading me to believe. This one's not so good. It's the last one I did. I think I was going a little too fast, maybe. First one, just about right. So the holes are all drilled, but the holes are not all exactly right. I have up to 1.25 inch Morris taper bit over there in my radial drill, and that is just kind of a net fit on these. I'm going to call them a galvanized female adapter. I don't know if that's what they're called, but I want to come up out of the base plate with these, and then when I run the conduit up the inside of the post, I need it to be galvanized, you know, EMT, is it called EMT? Whatever it's called. The metal conduit needs to thread into this. So not only are these holes just not big enough, but they are not perfectly located. So I'm going to carefully sort of burn them out a little bit where it's appropriate with my cutting torch. And once the non-shrink grout is in there under the plate and these things are in place, only you and I are going to know that the holes were not drilled quite right. Turned out I was wasting my time trying to cut these nice and square. I took them over to the steel outlet and they put them on their big bandsaw, chopped them off, so the ends of these are nice and square. I had them shear out some 1/8 inch plate that I'm going to use for making the capitals. So even though it's going to be 104 today, I think the shop's going to be a fine place to spend a little time in the shade welding and grinding. The downside to salvaged steel is you always have marks and mars and welds and holes in this case that you have to fill and grind away. That's where steel beats wood, because you can make a hole in steel absolutely disappear, unlike a hole in wood, which will always have, if you look closely enough, evidence of the fix. So I have two size holes. I have holes in these things that are drilled at 9/16 and holes in these things that are burned at 3/4. I've cut a bunch of plugs. I've chamfered them on one side. I take a backer plate and I clamp it, and I take a plug So I've had two of these things, and they're painful, and I tried cutting one of them off with a cutoff wheel, but I think the quickest, easiest, noisiest thing is just to grind them with that stone. So these boxes are the capitals, the caps on the columns, on the post and the column. I got to weld the perimeter, but I had to come up with some way to jig up to sort of build these using heavier stock than I needed, because I had 1/2x2 on hand, so I had it, you know, no additional expense. Being, you know, the kind of guy who likes to overthink things and always veering off towards the blacksmithing or bending side instead of just good old-fashioned fabrication, I thought maybe I could cut and bend this easier or faster than putting pieces together and welding it. So I made this monstrosity. That is, I just put the cuts in the bar almost all the way through and then bent it with a little heat, and it was just a giant waste of time. It just took longer, and the corners would have to be welded, and by the time I had made the 3 bends, it was no longer coming into a plane. And so, reason prevailed, and I just cut the pieces and ground a little bit of bevel, a little bit of relief to get some penetration at the corners, and it's just pretty easy to tack them together, and then I'll get them all in a stack and weld everything up at once. I did 3 of these capitals, running that long bead. I've got the machine turned up just about as far as it'll go. It's just a stringer. It's a pretty easy welder, it should be. But man, I was just having trouble. I was having porosity, and I realized, wait a minute, I can't see out of the lens anymore. The filters, the lenses over the filters were just dirty. So Ken and I just went down to Industrial Source, which is the local welding supply company that I use, and came back with fresh, clean lenses on the filters inside and out. What a world of difference. And I hope the next time I can remember, though I expect I won't, that when I'm having trouble with my welding process, probably there's at least a break-even chance. It's just that I can't see what I'm doing. Max power and nearly max wire speed. 030 wire. And finally they look pretty good. I mean, all I ever do is my welder impersonation. So Kenny's here today, keeping an eye on me. And since we are in extreme fire danger, he's on fire watch. And look what he pointed out under my welding table. Now maybe that would cause no problem, and maybe it would cause the kind of problem a man would almost never recover from. So I'm going to take care of that right now. Well, I've got a ton of grinding to do. I've got these capitals all welded up, and I am reminded again that there are a couple of types of fabricators. There are welders and there are grinders. And I am much more a grinder than a welder, but I think if I stuck with this, I would gradually transition more to the welder side of the equation. The trick always is to get the right amount of bead where you want it. Neither too much nor too little. And I did kind of a medium job of that on the corners of these capitals. But I've got all morning, and I've got a respirator, and I've got earplugs, so we'll just go ahead and clean up the mess. So one of the reasons a good welder is so valuable is because he reduces the amount of grinding that somebody's got to do. And frankly, grinding is much harder work than welding. I'm a little pooped. I've ground 4 of the 6 complete. I've got 2 more to go, and you know, I'm arm weary and my back is sore. But here's what I want to show you. Can you see that dirt line on my wrist right there? That's the line at the top of my gloves. All of this is steel and ceramic and aluminum oxide and paper and whatever else is in the grinding media that gets torn off with the grinders and thrown into the air and inhaled. You know, there's plenty of times that you've seen me grinding without wearing this, but I have to infer that if this is the difference between protection at the edge of a glove and your sweaty wrist out in the open, and by the way, this is all sparkly if you can't see it, indicating all kinds of metallic stuff. So if this respirator's even doing part of that good work for my trachea, alveoli, cilia, lungs, everything that's down the tube and in the middle of the operation, you know, maybe I'll just think a little more carefully about wearing this a little more consistently. Time to put these capitals on, and they have a few defects. Most of them are smoothed up pretty well, but the fact of the matter is they are only going to be driven by in a car that's going between 5 and 15 miles per hour, so therefore they're going to be great. Well, after that emergency design change from 3 posts to 2, which I think is going to end up being a happy coincidence, or you know, one of those disasters that turns out actually better than you had anticipated, or at least that's the way I intend to represent it for as long as I can. I'm almost paralyzed with sort of apprehension. I can't take Marcus Aurelius' counsel to don't fear the future, because you'll meet whatever challenges you find there with the same weapons of reason that you've confronted the challenges in the past, which have nearly failed me over the last 3 or 4 days. So I'm going super slow. I've got this tacked together, and I've had to mock up or jig up the best representation of square in 2 dimensions in parallel that I can do without getting it onto my fabrication table, which my crane won't reach. Besides that, I've got 1 or 2 holes that I've got to drill through this under the radial drill when the time comes. But first, I'm going to tack this together real good, take it out, set it on the roadside footing, and make sure I understand where the conduits are coming up before I take too many more steps in what I hope is the right direction. So initially, to hold this plate up, I just shimmed it up off this old weight. I've used every square that I own, both of these guys and a sheetrock square. I've clamped it together on wooden spacers, and I've got it coming up off the edge of the slab on oak spacers, sleepers if you will, that give me the same distance off of the slab as I need right here on the base plate. So, desperate times, desperate measures, but we're going to go out and do sort of a dry fit before we weld anything too hard. Well, I'm encouraged. I was apprehensive about getting this thing square in both directions to the plate in the shop on the floor, but I think it's going to come in just about right. Well, it's just like everything else. The first time you do it, it takes forever, and you're lucky if you get it right, and the second time it just falls into place. And so, after yesterday's ordeal of getting them parallel, in a plane, square to the base plate, and in place satisfactorily, today it took about, I don't know, 10 minutes max, maybe less, to get them where they need to be to start tacking. Practice makes perfect, usually. So this is my friend Greg Reitman. I've known him for about 15 years. He is the main man at Quality Fence, and they are the fencing contractor that's been around Roseburg the longest, as far as I know. Have I got that about right?
All right.
Yeah, miles and miles and miles of fence. And he's been coaching me on this, and there's plenty of coaching required with openers and closers and keypads, and so thanks for helping me, man.
You're welcome.
Have I hurt myself here yet?
No.
Oh, good. Oh, good.
You're going in the right direction.
Oh, good. He's got lots to show me and you about electromagnet latch, about location of hinges, about photo eyes to make sure we don't close the gate on anybody.
Yep.
There's a lot of safety concerns with this, yes?
There is, and you're required to adhere to UL 325. It's
Okay.
basically an entrapment device.
Okay.
So it's to prevent body harm, whatever, somebody trying to ride on the gate, something along those lines, to stop the gate in motion.
Okay. So if one of these grandkids gets out here and turns this into a fair ride, we're not going to squeeze them off,
Right,
man.
yes, it happens.
Oh, gosh. I bet you've got some stories, don't you?
That's right. That's right.
Well, thanks a million,
Safety
man.
first.
Safety first. I'm going to back up right now and show you 3 examples that might explain why I put 5 yards of concrete under the footings in these columns. The first one is forgivable, isn't it? Clearly a tight-budget residential fence project on black mud, and so you can't blame them for wanting to save the money on a footing under a post. But a tightly engineered project like this one, with a commercial entry that's going to be in place for decades on a busy highway, is quite another, isn't it? This is the saddest example of a gate post shifting. Even though I didn't bring a level and you can't see how much it's moved, it doesn't apparently even operate anymore. And over the years that I've been driving up here to Si's place, I've noticed it progressively getting worse and worse, and I think it finally will no longer serve its purpose, because this one does not have a grade beam. A MIG gun is so convenient. It's fast, it's clean, you don't have to chip off the slag, but it is not as strong as a really burned in bead of 7018. You know, a lot of the sticks, in my opinion, tend to push the weld in a little deeper. But I'm holding as short an arc as I can get away with really all of the power that this machine can stand. It's pushing it in there pretty good, and it's going to be more than strong enough and look more than good enough. You see that lovely blue color on that chip right there? And the bronze and the peacock scattered around there? What that means is I was turning too fast, feeding too hard, and was not putting any oil on the cut. And that, my friends, is a function of trying to run a GoPro with one hand and a radial drill with the other. It's been, I think, maybe 4 years since I've taken on any significant metal fabricating projects, and I've been missing it. And that's one of the reasons that I have enjoyed putting these columns together, because this is a pretty significant piece of fabrication. Lots of welding, lots of heavy single passes. Fillet welds is what they're called when you're joining two pieces of metal at a right angle to each other and trying to make sure that you get the same amount of weld up on each side of the 90-degree corner without any undercut and all the other things that a real welder would be looking for. But in general, I'm pleased with how this is going so far, and I'm very pleased with the opportunity to put a better gate in for my wife and for my kids and my grandkids when they come to visit. On top of everything else that Greg has had to sort of spoon feed me to make sure that this post assembly is going to work with the opener and everything, he set me up with the right pieces of pipe, galvanized pipe, to weld to the assembly to fasten the chain link fence to that he'll be putting on, I don't know, in 2 weeks or 2 months, whenever it is that we get to that point. But right now I'm going to weld these pieces of 1x3 rec tube to the sides of the wide flange and then weld the pipe to the rec tube. One of the things I've got to keep track of is this is galvanized. The fumes from welding galvanized pipe will certainly sicken you and can in fact kill you. So I've got to set up a fan and blow that zinc away when I finally get ready to weld. The trick is, when I blow the zinc away, I'm going to be blowing the gaseous shield from my MIG gun away. So I may end up having to turn my hat around, get out some 7018 and weld this with a stick. We'll see how it goes. Well, as you can tell, there are a lot of details, foreseen and unforeseen, a lot of preparation, just a lot of staging in order to be able to do a job like this. So in the next video, you're going to see two things. First, you're going to see how Curtis Eveland primes and paints these columns so they're ready to install, and how I dry pack non-shrink grout underneath their bases. And you're going to get a look at a temporary fabrication table that I build right in the middle of my shop, right underneath my crane, big enough to build a gate like this, pretty much perfectly flat, and still be able to get around in my shop, I hope. Thank you for watching Essential Craftsman, and keep up the good work.